Hey everyone, welcome to a video on composing functions, equation addition. Quick reminder, composing functions, or composition of functions, is a special functions only operation, right? That combines two functions, and this is the key thing, by using the output of one function as the input of the other. So we're not adding them, we're not multiplying them. We evaluate one function, and then that becomes the input of the next one. You've seen some examples, such as the following. Hey, look at that. We got these great little tables over here. We want to find f of g of 2. Well, if you were asked to find f of g of 2, we would start by looking for g of 2, which means that we would go to 2 in our G column in the input part, right? The X column. And then we look to see what is the output of that. Oh, it's 3. So we happen to know, right, that G of 2 is equal to 3. And now we can substitute this 3 in for G of 2. And so what we're looking for now is F of 3. And in the exact same way, we think of substituting this 3 in over there for the input. Make sure you can see that cool line I drew, right? Boom, right around. And so now, if we're looking for f of 3, right, we go to 3. We look for our output when the input is 3. Aha, we get 0. So we happen to know that f of 3 equals 0. 0 would be our final answer. We've done this. This is a review. We've done this with tables. What if we do it with equations? That's what we're going to do. Now I want to remind you the goal when composing functions with values. Our goal is to find the output of the inside function and use that value to find the input of the outside function. That's exactly what we did up here with the table. It's going to be the same thing with equations, right? We're going to use the exact same goal. We're going to do the same thing. Just going to be look a little different. Here we go. Here's our example. Ooh, we're asked to find f of g of 2, and we know that f of x is 2x plus 3, and g of x is negative x plus 6. So how do we find this g of 2? Well, this tells me that the input is 2 for the g function. So if I'm looking for g of 2, then I can't go to a table, but I can substitute 2 in for x here. So g of 2 would be negative 2 plus 6. Notice I just substituted in, here I had x and x, so here we have 2 and 2. And then we would evaluate this. Negative 2 plus 6, bleep blorp, that's 4. So g of 2 is 4. And now it's the exact same thing. Now we take this 4 and we substitute it in for the g of 2 there. And so now we're looking for f of 4. How do we find f of 4? Well, this is the same process, right? 4 is our input. So we go over to our f function. We substitute 4 in for x. We would say f of 4 is equal to 2 times 4 plus 3. Evaluate that. 2 times 4 plus 3 is 11. F of 4 is equal to 11. And this is like our final value. We would say f of g of 2 is equal to 11. Notice how we found that. We kind of did a two-step process. We found the output of the inside function, and that became the new input for the outside function. Okay, let's do one more example. Let's find g of f of, let's make 7. G of f of 7. That's a large value, but we can still do that. Let's clean up some of this stuff up here. Okay, so now I'm going to move this guy. Boop. That was cool. So if we're looking for g of f of 7, then we're going to start by finding f of 7. Substitute 7 in for our x value. F of 7 is equal to 2 times 7 plus 3. When we evaluate that, we get f of 7 is equal to 17. What do we do with that 17? You know, we take that 17, and that becomes the value that's f of 7. And we're now looking for g of 17. We substituted the output we got for the f of 7. How do we find g of 17? Hey, we're going to substitute 17 in for x. G of 17 would be equal to negative, in parentheses, 17 plus 6. Compute that. G of 17 is equal to negative 11. Therefore, I happen to know that G of f of 7 is equal to negative 11. We got that by doing 2 rounds of evaluating functions, starting with the inside. Now we've done this with tables, we've done this with equations. What if we did it with a table and an equation? What if we were asked to find f of g of 0? This isn't crazy. This isn't anything that we haven't already done. It just looks a little bit different. We start by looking for g of 0. G of 0, aha, g of 0, according to our a table, is 2. G of 0 is equal to 2. We take that 2, we substitute it in for g of 0. We're now looking for f of 2. Oh, there's no table, but that's okay. We're going to find f of 2 by substituting into x in our equation. F of 2 is equal to 2 times 2 plus 3. F of 2 is equal to 7. That doesn't get substituted anywhere because that is the final value we were looking for. We now know that f of g of 0 is equal to 7. F of g of 0 is equal to 7. There's one more example there. It's the same process. Maybe I'll leave that for us to explore. Hopefully that makes sense. Nothing crazy here, nothing brand new, stuff we've done, just working with equations. Bye for now.